Welcome to the FDTD Go 16 Applications webinar titled A First Look at GLM in AWIPS. This is presented by Chad Gravel from the NWS Operations Proving Ground in Kansas City. Next slide. And before we begin, just a few things to go over. All of these are recorded and made available on the visit web pages at the URL shown here. And also, if you're interested in leading one of these in the future, we're always looking for volunteers. Just let myself, Dan Bikus, or Scott Lindstrom know. Let us know if you're interested in leading one of these. Next. We'll give about 20 minutes for our speaker, and you can either send questions via the GoTo chat, or we will have a Q&A period over the phone after Chad is done talking. We'll be done by 19:30 UTC, and remember, do not press hold, and also remember to mute your phone when you're not speaking. So with that, I'll turn it over to Chad.
Hi everyone. So for the second presentation of the day, we're going to take a look at GLM and AWIPS. I was asked to do this, I don't know, maybe 2 or 3 weeks ago. Just to give a quick timeline, the Operations Proving Ground has had the GLM data for some time now. It's been the point data. And we learned pretty quickly that that's probably not the best way to visualize the GLM data. The infrastructure was there for Earth-based lightning detection systems like Earth Networks, NLDN, etc. But GLM is a different instrument, and so we learned pretty quickly that that AWIPS wasn't structured to handle it, and we felt that it would be confusing, to the forecaster. So they fixed some problems, and AWIPS can handle it now. And what we have now is a product actually that we're going to start distributing to the Weather Service, to the forecast offices, and it's called the Flash Extend Density product. And that product's been around for a while, especially if you're a WFO with access to a lightning mapping array. That data, and Jeffrey Stano at NASA Sport, who should be on the call, and he can help me answer some questions at the end if there are any. But he's done a lot of work with WFOs within those LMA networks and preparing them for GLM, and they've learned a lot. And I thought I'd give you a little taste on what the product will look like, and then at the very end, I'll try to do my best to give you a timeline of what's going to occur over the next couple months. So with that, I'll kind of jump right in. So I thought it would be a good idea to just go over what this product is. So the GLM, which is, as I said, an optical-based lightning sensor, observes total lightning. So it can't distinguish both cloud-to-ground and intra-cloud flashes. Some of the researchers feel like there might be a way to do that eventually, but it's just too immature right now. But it really observes total lightning. So there's two components of total lightning that are operationally relevant. So the first is total lightning is correlated to the strength volume of a storm's updraft in the mixed phase region. So that's a good thing. So when we look at convection, and we see things like an increase in lightning over a 2 to 3 minute period, that should be a pretty good red flag that updraft is strengthening rapidly with that storm. So that's one application, basically severe warning ops. And then the other one is GLM supports lightning safety by observing total lightning spatial extent of lightning flashes. So if you've heard the concept of a long flash in the stratiform region of an MCS, for example. So, the leading edge of the MCS moves through, you have the stratiform region behind, sometimes there's a lot of lightning in there. The GLM does an amazing job of detecting that lightning. And it actually does quite a bit better job than the Earth Network's lightning data set. And, that's my opinion, but I've been looking at this for some time now, and one of the reasons why I feel that way is because I can see the spatial extent much better. And some of those in-cloud lightning flashes way up in the anvil, they're pretty weak. So GLM, that's its strong suit. It's gonna detect those pretty well. So we have two basic applications. There's probably more, but these are the two that GLM will hit on pretty quickly for most of your forecasters. So we have this data. So how do we create this GLM flash extent density grid? So basically, what the flash extent density is, it's events. So it's the spatial extent, and then it's the flashes. So it's the best of both worlds in one product. So that we can make that product on the GLM grid on the left here, and you can see the footprint of this flash of this one flash is like this. But AWIPS can't handle that really well. So what we do is we take the footprint of that flash, and then we put the ABI grid on top of it, and what ends up happening is we create a product, we create this flash extent density product, and you can see that we take that larger 8 to 10 kilometer grid and basically downsize it to the ABI grid like this. And that is something that AWIPS can handle. So there's some that's basically the rough idea behind it. So because of time, I'm really only going to talk about total lightning and how it's correlated to the strength and volume of a storm's updraft and the changes within. There's a lot on lightning safety as well, but I'm going to really focus on this, and I'm going to show you 3 different examples, all on the same day, all in the same area. Okay, so let's get into it. So the day we're going to look at is April 21st, so that was 4 days ago. There was, this is the 1630 SPC outlook. You can see there is a slight risk across northern Texas, Dallas-Fort Worth area, and then slightly to the west. And in 1841, an MD was issued. I don't remember if a watch was ever issued, but there was an MD in this area as well. So this is where we're going to look. We're going to be pretty zoomed in. So it's basically west of Dallas-Fort Worth Metro, and then the third storm will be to the south of that area. So just to kind of get everyone oriented, I'm going to make it really, really simple. And I think that's kind of important when you're just kind of looking at this data for the first time. You don't need a lot of different products and radar data to kind of clutter things. We're going to really be focusing on the GLM. So on the top left, I have the lowest tilt of MRMS reflectivity. On the top right, I have that red visible clean IR sandwich product. On the bottom left, I have the GLM flash extent density grids. They're going to be on top of the red visible. And on the bottom right, I have Earth Network's total flash density. So before I go on, though, because I know forecasters are going to do this, I want to just caution you on comparing these bottom 2 lightning data sets, okay? So you can compare them, especially spatially. I think that's important. But when you're looking at the values, even though they're on the 1 minute time scale, things could be quite a bit different. There might be a lot more GLM flashes than there are Earth Network. So I wouldn't get concerned about the exact values, but just think about the spatial extent and where you have maxes, okay? So on this first example, we're going to look at data every minute for about 20 minutes or so. So here's 2006. 2007, we start to get our first indications of intra-cloud lightning. You can see GLM on the left, Earth Networks on the right. We'll go forward 2008, 2009, 2010, 2011. And you can see one of the things you may notice is the footprint of the flash is quite a bit larger in the GLM, and they're on comparable grid sizes than the Earth Networks. And that'll be a kind of a running theme, that the footprint is a bit larger with GLM than it is with Earth Networks. talk about how I feel about that, but it's just something for you guys to think about as you're kind of taking a look at everything. Here's 2012, 2013, and then 2014. I'm going to pause there. And again, take a look at the the extent of the flash and the signals for this intracloud lightning that you've been seeing. So one of the things that's confusing for people a lot of times after they've seen this data for the first time is that extent. But I want you to kind of think about, looking at a flash from above. Okay, so here's just an example. I don't know when it was from, but it was from the European Space Agency of a thunderstorm, and there's a lightning flash, and you can kind of see kind of what I mean, right? It makes sense. If you have a camera, we're going to just think of it like that, on Go 16, looking down, you can see there's going to be potentially a larger footprint there. So I just wanted to compare what you would see from a photograph in a way versus the product that you get in AWIPS. And they're not the exact same time, but I think it's interesting to think about, and it may help people visualize what's going on a little better and why there are differences. So we're going to keep going, 2015, 2016. Now you're going to see all of a sudden GLM starts to increase the lightning quite a bit. 2017, you can see that there's 9 flashes here. And I've done my best to have comparable color curves here. The GLM is going to be presented, a little differently than the linear curve. There's a log curve with GLM, and then the Earth Networks is linear. But I've done my best to kind of make them somewhat comparable. So here's 2018, and then 2019, and then 2020, and 21. You have another increase, and it's important to think about what these increases mean. So a very good rule of thumb over the course of 3 to 4 minutes, if you have a base state, so say you're getting flashes in the 2 to 3 flash range, somewhere in there, 3 to 4 even, and it just is hovering there, and over the course of 3 minutes, all of a sudden you get a jump that's 3 times that base rate, and this is just a rule of thumb, and that's kind of what we have here. We have an increase to 12 flashes. We can kind of consider that as a poor man's lightning jump. In a perfect world, we'd have a product that would be overlaid, that would signal us that a lightning jump has occurred with this GLM data. They're working hard on that. Chris Schultz down at Huntsville is working on that. The lightning jump algorithm that uses Earth Networks lightning data has been evaluated at HWT for a few years now. But getting that over to GLM is going to take a little time. But as a good rule of thumb, we could kind of use that 3 to 4 times the base rate for a lightning jump. So you kind of see that we have that here, and you can kind of take a look at the storm as we move forward, and you can see how that evolves. Here's 2024, 2025, and then finally 2026, the first convective warning was issued. So about, 6 or 7 minutes, there was that lightning jump, the updraft. Remember, there's a physical thing going on there, right? It's the amount of lightning, within that updraft, and as that increases, that's correlated to a strengthening updraft. You don't get that signal just by looking at CGs. So for convective warning ops, honestly, CGs aren't important to have on your display. It should be a total lightning field, because that is going to give you information and give the warning forecaster information. And the first tail report after the warning was issued was about 30 minutes later. It was a 1-inch report, and that's the location of that report, well within the polygon there. So that's one example, okay? So now we're going to jump ahead about 90 minutes or so. You can see that convective complex to the north, which we've been following, still has severes out with it. Pretty good lightning with that storm as well. But we're going to focus down on the lower part. So there's developing convection here that we're going to take a look at. So we're going to move forward, and now we're going to jump by 5 minutes, just for in lieu of time. So, but we're still looking at data, lightning data, that was just from the previous minute. So between 22:16 and 22:17, there was a pretty good increase with the developing convection to the south, an increase of 12 flashes. We jump ahead to 22. It kind of remains somewhat steady state through 22 and 27, and then there was another increase over the last minute, 23 flashes. So you can see that there's probably there was an initial lightning jump, and then there was a secondary one. Things are starting to evolve, and just quickly comparing to Earth networks, you can see that the maxes are there, right? So there's a max of about 22 flashes in this pixel from Earth networks, and then probably close to 40, 45 with this white pixel here to the north. And you can see that, again, in the GLM, but what the GLM provides is just, in my opinion, it's just an easier footprint to interpret, because you can see how the forecaster may, these are very isolated pixels here, and you can see the maxes within the GLM flash extent density footprint, are there, and it may potentially be easier for the forecaster to gravitate towards. I'm not sure. It is for me, just because of that reason. Just because there are isolated pixels with the Earth networks data, but the signal is there. You just need to understand how to pull it. At 2237, 2242. 2247, and you can see how this is evolving. And then at 2249, a severe was issued. So that lightning jump preceded it by about 10-15 minutes or so. And then about 20 minutes later, there was a 2-inch hail report, again, well within the polygon. So you can kind of see how that part of the storm evolved. So we're going to look at one more example. We're going to cut this down to a two panel just to kind of zoom in a little more and maybe make it a little easier. So we have the GLM on the left, and then we have that same MRMS lowest tilt reflectivity on the right. And this time we're going to look at imagery every minute over the course of 10 minutes, and we're going to just focus in on the north. And this one's kind of interesting because it shows you how fast something can evolve and how quickly it can evolve. So here's 2341, 42, 43. You can see a new severe was issued to the south. 44, 45. So all of a sudden you get that very nice signature in GLM that is associated with this cell to the north of that severe. 2346, there's a 23 flashes, 2347, 2348, 2349, 50, and you can see in 51. So we're talking only, I've only shown you 10 minutes of data, and you can see how quickly that updraft is strengthening in that spot. And that's 2351, and then the next frame I'm going to show you is when the severe was issued, which was about 15 minutes later, actually probably 13 or so. But you can see, one of the great things about this total lightning data, and especially the GLM in the time that I've looked at it, is these signals are here, and they're quite easy to pull out, and you can just think about the situational awareness it can provide to the mesoanalysts who may be supporting the warning forecaster or the warning forecaster on their own. And you can see on this one, there was 8 minutes lead time for the first hail report, which was 1.5 inch report within that polygon. So those are the 3 examples I have. And so what now I'll go through is at least what we know right now about how we're going to get this product into the WFOs. So starting tomorrow, we've been working on this for about a month now. We're going to have a preliminary test and evaluation of this product. It's not going to be an evaluation on how to use the product, but more about performance of the product in AWIPS. So we're going to do that, and that's going to begin tomorrow. And the WFOs that are associated with this PT&E are Huntsville, Melbourne, Sterling, Lubbock, Boulder, Houston, Raleigh, Norman, and then Fort Worth, and their associated CWSUs if they have them. So these WFOs were chosen because the majority of them have traditionally been within a lightning mapping array network. And remember, this is just, we've gone through this lightning data quite a bit in the operations proving ground. We've reduced the latency of it. The latency is about 2 minutes or so, give or take. So it gets to the forecaster, or it gets to the WFO very quickly. There was an AWIPS performance issue we cleaned up as well with the developers that are developing this product. So we feel that what's going to get to these WFOs tomorrow is probably about 97 or 98% there. But it's good to have these WFOs look at this data. They're going to look at it for about 3 weeks, and then the goal over that time, as I said, is to confirm the stability of the GLM grids with respect to missing data. So if there's data dropouts, latency, are we getting to a latency of 3 minutes or more? In my opinion, that's about as much as we can get for lightning data. We really want something in the 1 to 2 minute range. AWIPS performance, if you're overlaying this data with satellite imagery, things like that, other data sets, how does AWIPS perform? And then AWIPS display is the color curve, at least the initial one that I've shown here, is that going to be sufficient for forecasters? So if that PT&E is successful, which I'm confident that it will be, then details about a wider rollout of this GLM flash extend density product to all WFOs via the LDM will be communicated probably in the 3rd week or so of this evaluation. So hopefully in about 3 weeks or so on how that is going to be rolled out. But the initial plan is this will be offered to any WFO that would like the data, but we will probably roll it out in chunks of WFOs. And we're probably going to do that based on severe climatology potentially. Those details are still getting ironed out, but hopefully that will be communicated in a couple weeks. And the reason why this is going to be transmitted via the LDM initially is because of this product, because it's only been about a month old now, is tentatively scheduled to be included on the SBN not until September 2018, and we really don't want to wait another convective season. I've been looking at this data, and it's quite good, and we really just want forecasters' eyes on it, in the field. So that's why there is this push by regional SSDs, National Weather Service Office of OBS, and us included at the Operations Proving Ground to get this data in front of forecasters' eyes. So with that, I'm sure there are questions. Jeffrey is on the call. I'm here, obviously. So fire away. That's my last slide. I'll leave this one up.
Hey, Chad, since you've been looking at this stuff for so long, what is the typical latency or difference between a subjective lightning jump and the associated severe weather as a very rough rule of thumb?
So the latency, so if I have a cave time of say 1924, the GLM product that I have loaded time matched to that GLM is either 1922 or 1923 on average. So it's pretty fast. It takes about, so if you think about it, the data gets to AWC, that's where this data is being processed. So if you think of lightning between 22 and 23 past the hour, at the 23 minute, that data is being pushed to AWC. It takes about 50 seconds to process it, and then it only takes seconds after that happens to get to the WFOs. Because we're using a direct LDM connection that was implemented I don't know, maybe 6 months ago. I can't exactly remember. It bypasses LDAD, so it's actually quite a bit quicker. So that's why it's kind of in the ballpark of a minute or two. So I mean, it's still on the order of, if you think about it, 1 minute imagery. Go 16. That's probably about the latency we have. Sales is probably a little longer because it's 1 to 2 minutes. But so the latency is still pretty good. So when you see these jumps, that jump probably occurred about, if you're looking at the last 2 to 3 minutes of data, kind of like what I was looking at in these 1 minute imageries. That jump probably happened about 4 or 5 minutes ago. But it's probably still a good indicator. So because you saw how those jumps were occurring probably on average about 10 minutes or so before a warning was issued. So to me, it's when you think about that rule of thumb of that 3 to 4 times the base values, it's really about situational awareness. So the warning forecaster is looking at the data on a situational awareness screen. They notice a jump. Boom, they can immediately go to that storm and do triage. They can, if they're on the fence, in my opinion, that should probably push them over, similar to other data sets like Prob Severe and things like that. So, it's sometimes that, you hear about waiting for another volume scan, and that's what I think this data can really help provide. It can push the forecaster to pull the trigger. And at the very least, it could push the forecaster to get the polygon ready for sure. I hope that kind of helps. It was a bit long-winded, but...
So try your homework of it,
Any other questions out there?
Is there any ability to archive the data, or say we wanted to look at a case from a previous day, or maybe we failed to grab an image locally? Is there a way for us to go get some data that we could then use as a training exercise?
There isn't anywhere publicly yet. So, here we have a 5-day rolling archive of this data. So we can, and the files are like so small that, isn't that right, Matt? That these files are pretty small, on the order of hundreds of kilobytes. So,
Are you talking about the grids?
Yeah, the grids.
The grids, what's initially coming to the field, it'll typically be like less than 100K for the raw files. Now the processed data will be quite a bit bigger, but because the vast majority of the area is not going to have lightning strikes, the raw data compresses extremely well.
So the reason why I bring that up is we could potentially, and the OPG is in the business of being the National Archive, but we have helped out, people that really want to use this data for a specific application, like a training, obviously. And there will be training coming out. So we can probably, deal with a couple of requests. One of the things we don't have set up yet, which we probably will eventually, is to run a past case. But we're going to try to get that set up. So, because really the biggest change, the GLM data was pretty raw, until about late November. And then there was a couple big improvements, and the data just really got quite a bit better. So anything from basically 2018, once we get that capability to, to process the raw data into these grids, at least at the OPG, because we can do it on the fly, obviously, but not in archive sense yet, that anything in 2018 would probably be fair game and probably be good quality.
Any more questions for Chad?
One more, real quick, to just give our forecast staff a refresher briefing as they might look at this data and check it for latency during this quick test period for 3 weeks. Is there a single reference or something quick and easy we can pass along to them as just a starting point in terms of the data?
Is that Pete?
No, this is Jonathan and Ryan and Raleigh.
Jonathan. Yeah. So tomorrow we're going to have this kickoff call with these PT&E WFOs, and we're going to give them a little introductory into GLM, about 10 minutes, and then we'll pass along those slides, and then we're also going to give a one-pager that basically has that information condensed. So we'll get that one-pager to these PT&E sites, but if anyone else out there would like a version of that one-pager, just contact myself or Jeffrey Stano, and, I don't have any problem, getting that to Suze ahead of time so they can take a look at it and send it to their forecasters. So in about a month or so, when this data potentially is flowing, they could be a little more prepared. And we will do some training for when we roll it out wider. We'll probably have a couple training sessions that are identical each week for about 2 or 3 weeks. We're going to want WFOs to obviously have some kind of focal point, sign up for those so they have a little bit understanding about this data. Because as I showed, it is a bit different than Earth Network. So it's just good to have that understanding. So hopefully that helped, Jonathan.
This is Jeffrey. What we're going to try to do with, as Jeff was saying, these kind of one-pagers, we'll be sending out, basically it's the quick guide, very similar to what you've probably been seeing through the stat process for the other Go 16 products. We're trying to basically make sure that it's in the same style and format so that kind of thematically it matches up with everything else that we're seeing and allows you to kind of quickly reference what is a GLM, how does it look, things like that.
Okay, any more questions for Chad? Hearing none, we want to thank Chad for leading today's webinar, and thank you everybody, and have a great day.